IGCSE Computer Science, Syllabus Statement 1.2.1d, distinguish between synchronous and asynchronous data transmission. Now I know what you're thinking, probably. You might be thinking, hang on, this statement isn't in the syllabus, why do we have to know about this? Well, you do have to know about this, because in the introduction we discussed the direction of data transmission, which was simplex, duplex, and simplex, half duplex, and full duplex, and the method of transmission, so serial or parallel. But this is the synchronization, the method of synchronization. Now, although it isn't directly referred to in the syllabus, you still have to know about it. So, again, this ties into what we've learned in the last 2 videos. So we just have to learn this, and then we're pretty much done. Then we can discuss, you know, all the reasoning and all the examples, and we can finish this topic off and then move on to security, although there's already a whole topic about it. But anyway, we'll get onto that when we get onto that. So let's learn about this. So let's start with synchronous. So synchronous data transmission is data which is transmitted as a continuous stream. And the way this is done is timing signals are used, which are generated by an internal clock. And this ensures that the sender and receiver are in sync. So this is basically all about data being transmitted, but like the timing also sort of tying in with this. So like the timing of the bits being sent. And the receiver will count the number of bits sent and then reassemble them into bytes of data. And again, timing has to be quite accurate in this type of transmission because there are no control bits being sent. But this is a faster method of data transmission than asynchronous. So there's always a good side. So asynchronous, that being said, asynchronous is data transmitted in an agreed pattern. So the bits are grouped together and sent with control bits. So there's a start bit and a stop bit. So this is the data, start bit, stop bit. And this way the receiver knows when the data starts and when it ends. And of course this prevents data being mixed up in transmission, which obviously can be a bad thing. Now, what we also looked at was MIDI quite a few videos ago, and we talked about how MIDI used asynchronous data transmission. So that's basically what I meant. So when I said that MIDI uses a start bit and a stop bit and that it's asynchronous, this is pretty much what MIDI sort of does. So that's sort of the idea.